Today on Capechi's Corner, we are going to look at medians, altitudes, and perpendicular bisectors, and this is day 2. Let's look at the given diagram. In number 1, it says if AB is equal to BC, what's the median of triangle APC? So let's mark it. AB is equal to BC. The median, remember the word median means in the middle. So right here, PB is the median of triangle APC. In number 2, it says if segment PC is a perpendicular bisector of something, then BC is equal to DC. So again, let's mark it. If segment PC is a perpendicular bisector, so we know it's perpendicular, and we know it's going to bisect something, then we're saying BC is equal to DC. So that means BD is going to be our answer there. So if segment PC is a perpendicular bisector of BD, then BC is equal to CD. In number 3, it says angle, if angle APD is a right angle, so let's mark that APD is a right angle. What are the altitudes of triangle APD? So that's a big triangle on the outside. So the altitudes there are going to be segment AP, that's going to be an altitude because that's coming from a vertex of that triangle to the other side where it meets at 90 degrees. And also DP will also be the altitude for the same reason. DP is coming from the vertex D to the other side to meet at 90 degrees. So here is one altitude and here is the other altitude of triangle APD. That's 2 of the 3 altitudes. In number 4, it says if segment PC is a median of triangle PBD, then it's looking for an equality statement. So PC, segment PC is a median of PBD. So here's PBD is this triangle right here we're looking at. And median, remember, it means in the middle. So if that's the case, then BC is equal to CD. Now in number 5, it says if BC is equal to CD and segment PC is perpendicular to BD, then blank is a perpendicular of blank. So let's fill that in. So we have perpendicular and we have equality there. So it looks like we have a perpendicular bisector. And so then this segment PC, that's the perpendicular bisector. It's meeting at 90 degrees and it's dividing it in half. The bisector of segment BD, because that is the segment that's being divided into 2 equal parts, and is also meeting PC at that 90 degrees. In number 6, it says if segment PC and segment AC are both altitudes. So let's mark that. PC and AC are both altitudes of PCA. So we're talking about this triangle right here. Name a right angle. Well, because I marked that diagram, it makes it a little easier for me to see. My right angle is angle ACP. Let's look at a different diagram. So we have in number 7, it says if ray BX bisects angle ABC, so let's mark that. If ray BX, that's my angle bisector, bisects angle ABC, then I can say angle ABX is congruent, right? This one is then going to be congruent to angle CBX because of where that angle bisector is placed. Number 8 says if segment DX is the perpendicular bisector of segment EB, so let's mark that. DX is the perpendicular bisector of EB. Now again, it might not be drawn to scale, but there's my perpendicular bisector, perpendicular and divides it in 2. Then segment ED is equal to segment DB. And then we also know that segment XE is equal to segment XB because I now have 2 congruent triangles there. So again, marking up the diagram definitely helps you answer these questions. In number 9, it says if XB is equal to XF, so let's mark that. XB is equal to XF, then what is the perpendicular bisector of BF? So we're talking about this segment here, and in that case it's going to be segment XG is the perpendicular bisector of segment BF, and angle XBF So XBF, this angle right here, is going to be congruent to this angle right here, angle XFB. We have an isosceles triangle. Triangle XBF is an isosceles triangle. And so if the sides are congruent, then the angles opposite those angles are also congruent. In number 10, it says if XD is equal to XG, so let's mark it. If XD is equal to XG, then what is the bisector of an angle? So let's take a look at this. I have congruent triangles here. So right here, I can say that ray XB is the bisector of angle DXG.